Okay, let's talk about the single most important thing in our modern world that you've probably never really thought about: semiconductors. I mean, these things are the invisible engine powering, well, literally everything. From your phone to your car, it's all running on chips. And if you want to understand our future, you absolutely have to understand these.
So, to really get our heads around just how important they are, let's do a quick thought experiment.
I want you to really picture this. What if you woke up tomorrow and every single semiconductor, every microchip on the planet just vanished? Poof, gone. What would the world actually look like?
Well, the honest answer is, our world would just stop. And I'm not exaggerating when I say we'd be thrown back 100 years, instantly. Forget your phone or your computer, that's obvious. But even your car wouldn't start. Your TV wouldn't turn on. Your refrigerator would be a useless box. We are completely 100% dependent on these tiny, tiny pieces of silicon.
So how on earth do we make these little magical things that run our entire civilization? Well, the process is, frankly, mind-boggling. It's about turning one of the most common things on Earth, sand, into a technological superpower.
Now this is super simplified, but it basically boils down to a four-part journey. You start with regular old sand, you purify the silicon out of it, and then you melt that down into these huge, perfectly formed cylinders. Then, you slice those cylinders into wafers thinner than a piece of paper. And that's when the real magic begins, an unbelievably complex process of printing microscopic circuits onto that wafer, a process that can take literally thousands of individual steps.
Of course, this didn't happen overnight. I mean, we went from these giant clunky vacuum tubes back in the 40s to the first integrated circuits in the late 50s. By the 70s, you had microprocessors running everything from calculators to the Apollo missions. But then, in the 90s, something fundamental changed. The factories, or fabs, became so insanely expensive to build that the industry was forced to split apart into highly specialized roles.
And that big split? It created what we now call the global value chain. You can think of it like a massive, planet-spanning conveyor belt, where each company has one and only one super specific job to do.
And this is the most important thing to get. No single company, not even the biggest names you can think of, does it all from start to finish. The real power of this industry, its secret sauce, is this incredible level of specialization.
So it all starts right here, with what you could call the brain of the whole operation. These are the companies that deal with intellectual property and design tools. They don't make any physical chips. Instead, they create the fundamental blueprints and the insanely complex software that everybody else in the chain depends on. Here's a good way to think about it. These guys are the architects. They're the ones who design the foundational structure of a skyscraper, the steel beams, the core layout, long before anyone else even starts thinking about what the offices will look like. Then you have the next step, the chip design companies. These are the names you've definitely heard of, like NVIDIA or Apple. They take those basic architectural blueprints and design a very specific chip for a very specific job, say making it incredibly powerful for AI or super power efficient for a smartphone. But, and this is key, they're fabless, which means they don't actually build the thing.
So, sticking with our analogy, if the first group were the architects, these companies are the car designers. They're the ones deciding the horsepower of the engine, the sleek aerodynamics, all the cool features, but they don't own the factory that actually bolts the car together.
That incredibly difficult job belongs to the foundries. These are the mega factories that take all those brilliant designs and physically turn them into real working silicon. We're talking about one of the most complex and eye-wateringly expensive manufacturing processes on the entire planet. Building just one of these factories can cost billions and billions of dollars.
They are the car factory. They have the billion-dollar machinery, the deep expertise, and the massive skill needed to actually build the engines that everyone else designed. This fundamental split between design and manufacturing is the engine that makes the whole modern world work.
So here's the question. When you have a global supply chain that's this specialized, this complex, what happens when just one link in that chain snaps? Well, we all found out the hard way, didn't we? Back in 2020.
It was a perfect storm, really. When the pandemic hit, the big car companies totally panicked and canceled their chip orders thinking nobody would be buying cars. At the exact same moment, demand for laptops, webcams, and cloud servers went through the roof because we were all suddenly working from home. So what did the foundries do? They just shifted their production lines over to meet that new demand.
The problem was, when the car companies realized people were still buying cars, they came back, and the manufacturing capacity they needed, it was gone. It was booked solid.
But that crisis has evolved. The shortage didn't just go away. It shifted to a new, and you could argue even more critical part of the economy.
Because here's the new reality. You've probably heard the saying, data is the new oil. Well, if that's true, then AI companies are the new oil refineries. And those refineries are absolutely desperate for the processing power to make it all work.
So the whole bottleneck has moved. The big fight isn't just about the relatively simple chips that go in our cars anymore. No, now the biggest, richest tech companies on the planet are in an all-out war for the highest-end AI chips, booking out the world's limited foundry capacity for years into the future. This crazy level of competition, combined with how fragile we all learned the supply chain is kicked off a brand new geopolitical race. Every major country on Earth now realizes that if you don't have some control over chip production, you're vulnerable. So let's take a look at India as a really interesting case study here.
India is making a very serious play. The government has put a staggering 76,000 crore rupees on the table to try and build a chip ecosystem from the ground up. I mean, that is a massive statement of intent.
But here's the thing. Money alone can't solve this problem. This chart shows you the brutal reality. With chips, the smaller the number, we're talking nanometers here, the more advanced the chip is. The global leaders are making chips at an incredible 5 nanometers. India's current capability? It's closer to 40 nanometers. That isn't just a small gap, that's a huge technological chasm to cross.
So India is making a very strategic long-term bet. And it does have some huge advantages on its side, right? A massive domestic market, strong IP laws, and a reputation as a trusted partner in a world looking for alternatives. But the challenges are just immense. The insane amount of capital needed, navigating those tangled supply chains, and of course, closing that giant technology gap.
And all of this brings us to the final, absolutely critical question for the next decade. If these tiny silicon chips are the engines of the modern economy, and in a world where data is the new oil and AI is the refinery, who is going to control the factories that build those engines? That's the real prize. And that race is really just getting started.